Okay, we are now on question 2. So this is the sequences and series part of this paper. And we have question 2.1, which says the first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. Okay, a lot of information they're given. And they want us to calculate the sum of the series, which contains 20 terms. Okay, let's go ahead and start off with this question. So, in the information, you see that they're giving us that the first term of this series is 7. When they tell you the first term of an arithmetic or a geometric, you can call that A. So they told us that A is equal to 7. And then the common difference of the series is 5. So we know the D value. So D is equal to 5. And we have to basically find the sum of 20 terms. Okay, so it's the sum of series formula for an arithmetic, but it's the one with D because that's what they gave you. So we're going to say Sn is equal to, and you have the formula in your formula sheet. So here it is. And then we're just going to substitute. So S of 20 terms is equal to, in place of N, that is 20 over 2 multiplied by 2, and A7 plus N, which is 20 minus 1, and then times 5, which is D. And then you can just punch that into your calculator and find the answer. And you see that that is equal to 1090. Okay, that is it for that question. Moving on to the next question. The next question, 2.1.2, says the original arithmetic series is extended to 75 terms. We should write that down. So we have what they told us to find was the sum of 20 terms, right? But they're saying that this arithmetic series that we have, it is extended to 75 terms. So it goes all the way to 75 terms, so T75. Then the sum of these 75 terms is 14,400. That's also very important. I'm just going to try to find a way to just like put them all together. So the sum of it, let's just say, we calculate the entire sum, and then that would give us that 14,400. Then they say, using sigma notation, write down an equation for the sum of the terms added to the original series. So we need to write it in sigma notation first of all, but it needs to be the sum of the terms that have been added to the original series. You know that the original series, right? Where they spoke about this, they said we ended at term 20. So 20 terms. So the original series had 20 terms, which should be probably here. And then they are now saying that this gets extended. So you need to write an equation for the sum of terms that have been added. If there were originally 20 terms and you knew that the sum of those 20 terms that we found was 1090, so if we know that this is the sum of the 20 terms, how do we know what was added, okay, to get the total sum of 75 terms? Well, we would actually have to find the remaining part of this part that we have not expressed. And we can find out how many terms there are here. So if the original series had 20 terms, then it got extended to 75 terms. The remaining series that you have, the amount of terms that you have here would be 55 terms, okay? So because 20 terms plus 55 terms would give you the total of 75 terms. So what they're asking us to express in sigma notation is an equation for these 55 terms. Let's go ahead and do that. So you see with sigma notation, you need to have the Tn formula because you know you have sum and then you have the Tn formula over here. So let's actually find that first. So Tn is equal to, and we're going to use this pattern that we have. That's what we have, and we will use that. So we have to find the Tn formula. Okay, so Tn is equal to, let's go ahead and find it. So we already know A, we know what D is. So Tn is equal to A, which is 7, plus N minus 1 times D, which is 5. So that's what we have over here. Okay, now that we have this, I guess we can just simplify it a little. So 7 plus, and let's distribute. So times and multiplies. So that's positive 5n minus 5. And if you simplify this, this is 5n, and 7 minus 5 is positive 2. So this is our Tn formula. Now let's go ahead and write it in sigma notation. So this is the final part. We're just going to say this is the sum, right, of the series that has this formula. So 5n plus 2, right? And then we need to tell them what that series is equal to, what the sum of it is equal to. And here's where you have to do a calculation. You see that we already had the sum of the first 20 terms, right? And we also have the sum of the first 75 terms. But we're trying to focus on the sum of these 55 terms. So how much would that be? What would be the sum of the 55 terms? Well, you could say the sum of the 75 terms minus the sum of the 20 terms. And that would give you the sum of the 55 terms. Okay, and that's the number we get when we take the sum of the 75 terms minus the sum of the 20 terms. We know that these, right, when you add them, their sum is going to be 13,310. Now, I don't want to call it S of 55 terms because technically it's not S of 55 terms. And here I'll explain why. So I know that the sum of it gives us 13,310. The reason I don't want to call it S of 55 is because if you say S of 55, you're saying the sum of the first 55 terms. These are not the first 55 terms. These terms start here after the 20 because the sum of the 20 is from term 1, then term 2, term 3, all the way to term 20. So these terms start at term 21. Okay. And so that's why I don't want to call it that. And I think that explanation already covers this part. So here is how we're going to write this. Remember that you need to tell them where your sum starts, your terms start. We are going to start because we're using n here. N is equal to, you cannot start at 1. Again, this is not the sum of the first 55 terms. It's the sum of these 55 terms. And it starts at term 21. So n needs to start at 21 and end at what? So that it's a total of 55 terms. It must start at 21 and end at 75. So you end at 75. And here we can actually confirm that these are indeed 55 terms. To find the number of terms, you say the top minus the bottom plus 1. That's the formula. So 75 minus 21 plus 1 is indeed 55. So that is going to be our equation in sigma notation. Okay, so that is it for 2.1.2. Moving on to the next question. Okay, we are on question 2.2 and it says, the sequence of the first differences of a quadratic pattern is 1, 3, and 5. So that's the first differences specifically of a quadratic pattern. And then they say if term 99 of this quadratic pattern is 9,632, calculate the value of term 98. Okay, so let's lay down everything they have told us. So first of all, they're telling us the first difference of a quadratic pattern. Here's how these are structured. So remember the quadratic pattern, you would have your first term, second term, and just for the sake that they gave us 3 terms, let's just include 4 terms here. So we have 4 terms. And in these 4 terms that we have, they told us that the first difference of these terms are 1, 3, and 5. Okay, so here's what we can actually take out of that. So how we will get these is simply by saying this term 2 in your quadratic minus term 1, and that's what's going to give you the 1. And then term 3 minus term 2, that's what's going to give you the 3. And term 4 minus term 3 will give you the 5. That's how we have those. Okay, so here is what they're actually telling us. They told us that if term 99, okay, so term 99 is, let me just leave that in green. Term 99 is 9632. We need to find the value of term 98. Okay, why don't we just see the relationship between how term 98 relates with term 99? Do you see that in order to actually get term 99, you're going to have to say term 98 plus a specific first difference, and then it will give you term 99. So that means that you need to find out what first difference was added to term 98 to get term 99. So that's our goal now. Now, to find this, you can actually think about it like this. We're trying to find out what term in the first difference, which term in the first difference is between term 98 and term 99. You can look at it here. For example, look at this. You see 3? 3 is the second term in your first difference. It lies between the second and the third term in the quadratic pattern. Likewise with this 5. 5 is the third term in your first difference. It lies between the third and the fourth term in your quadratic pattern. So if this lies between term 98 and 99, then that means that this is term 98 of your first difference. Okay, so here now we know. All we have to do is find out the value of term 98 of our first difference. We can easily do that because we have 3 terms in our first difference. And the first difference is an arithmetic pattern. So the formula of an arithmetic pattern is Tn is equal to A plus n minus 1 times D. And then term 98 is equal to, and we're saying A, which is 1. Okay, that's the first term in your first difference. Plus 98 again minus 1, and then multiply by D. What's the difference? Oh, to find the difference, you just say term 2 minus term 1. And as you can see, that actually just gives us 2. 3 minus 1 is 2, so 2. Okay, so let's go ahead and punch that in and find out what exactly term 98 is on our calculator. Okay, and we get 195. Okay, so we know what that is. And finally, to find out what term 98 in your quadratic pattern is, because we don't have any other information, we don't even have its formula, we can just say, since term 98 plus this number 195, right? Since that is going to give you this number 9632, then how would you get term 98? Just move backwards. So you're starting from term 99. Because you added when you were going this way, you must subtract when you're going backwards. So term 98 is going to be found by saying 9632 minus 195, and that's going to give you term 98. Sorry about that. Okay, that gives us 9,437. So there we go. Term 98 of the quadratic pattern is that number. You can also just make that clear because you have a 98 there, but that's for the first difference. Okay, so there we go. I concluded with that. Okay, so that is it for that question. Moving on to the next question. Okay, and then 2.2.2 says, if it is further given that the third term of the quadratic pattern is 32, so quadratic pattern's third term, determine the general term Tn of the quadratic pattern. Okay, if you don't really know what they mean, then just take your pattern again and then just substitute what they were referring to. And then we'll be able to see the bigger picture here. So this is already what we had. And they told us that the third term of the quadratic pattern is 32. So the third term is 32. And you have to now use this information to find the Tn formula. Okay, so let's see. You know that to find the Tn formula, all you need is the first term in the quadratic, first difference, and second difference. The only thing missing is this. So how do we get the first term in the quadratic? Well, we can just work backwards like we did with the term 99 to get the next term, because these are positive. When you're going forward, you're adding them. So when you're going backwards, you're subtracting them. So to get term 2, you say 32 minus 3, and it'll give you term 2. So I don't really see any need for calculation, but yeah, sure. Term 2 is 32 minus 3, and then we'll just put that down, which would be 29. So we have there 29. And then how do you find term 1? You would say 29 minus 1, which gives you 28. So there, term 1 is equal to 29 minus 1, which is 28. Okay, now that we have these, we can finally find that. So remember just to equate them to what they should be equal to. This is 2a is equal to, this is 3a plus b is equal to that, and this is a plus b plus c. Okay, let's go ahead and find this. So 2a is equal to 2, and then solve for a. That means that a is equal to 1 because we divide both sides by 2. And now that we have a, 3a plus b is equal to 1, but we already know what a is. It's 1. Okay, so that's actually b is equal to 1, and then we have 3 times 1 is 3. Take it over, it's minus 3. So b is actually negative 2. And then c, we have a and b. So we're saying a, which is 1, plus b, which is negative 2, plus c is equal to 28. And then just solve here. So c is equal to 28, and then 1 minus 2 is negative 1. If you take negative 1 over, it becomes positive 1. So that's 28 plus 1, which is 29. So our Tn formula is Tn is equal to, so an squared, but a is 1, so it's n squared, plus bn, but that's negative 2, so negative 2n, and then plus c, which is 29. And that is our Tn formula. Okay, so that was the last question for question 2. And moving on to question 3. Okay, we are on question 3. Question 3 says, a circle with a radius 6 centimeters is drawn. Okay, so we have the circle with radius 6 centimeters. I think it's better to draw it here. Okay, and then they tell us that a second smaller circle is drawn through the center of the first circle and also touches the first circle internally. Let's actually just speak about what that means. You see, they told you that you have a circle. That's that bigger one, right? And then there's another smaller circle drawn. And the radius of this circle is 6. So here's the thing about it. Because the second circle passes the center of the bigger circle, right? And it also touches its circumference. You look at the bigger circle, from the center to the circumference is the radius. And they told us that that was 6 centimeters. That would mean that in reference to this second circle, that radius is actually a diameter, because it's going from one part of the circumference to the other part, and it passes its center. Okay, and then the same thing happens with this other smaller circle. See that this other smaller circle, what would be the radius of the second circle, see, from the center to the circumference, what would be that radius is actually the diameter of this smaller third circle. Okay, so you can see what keeps happening. It's just like circles being drawn inside circles, and they're really just going to keep on being cut in half. Okay, and then they tell us a third circle is drawn through the center of the second circle and touches the second circle internally. Same thing. So the process of drawing circles continues and forms a geometric pattern. Okay, the question is, write down the radius of the third circle. Okay, let's expand this pattern, because it is a pattern. It's a pattern of the radiuses of these circles. So the first circle, let's look at the first circle, the bigger circle. We already know that the first circle's radius, and I'll call that term 1. I actually wanted to call it radius 1, but I don't want to confuse the R with ratio. So term 1, the bigger circle, its radius is 6. We can see that. Then what happens with the radius of the second circle? The second circle's radius is going to be half of this, because you see the second circle? This 6 centimeters is its diameter. So its radius is half of it, which is 3. So that's going to be 3. And therefore, this would mean that the third circle, term 3, so this circle, its radius is going to be, so as you can see, this is the diameter of this bigger circle, but it's the radius of the second circle. So half of it would be the radius of this third circle. So you're really going to take that radius that you have and you cut it in 2. In other words, multiplied by a half. So 3 times a half is 3 over 2. And that is your answer. So the radius of the third circle is 3 over 2 centimeters, because they're in centimeters. Okay, there we go. I don't think we really need a calculation there. Okay, moving on to 3.2. 3.2 says calculate the sum of the areas of the first 10 circles. Okay, so they specifically want areas. How do you find the area of a circle? The area of a circle is found by saying pi r squared, which is perfect because right now we have a pattern telling us the radius or radii of these circles. So let's go ahead and expand what this pattern is going to look like first of all. Let's look at what the area of the first circle will look like. Remember that the radius of the first circle is 6. So to get that, T1 is going to be pi and then radius is 6 squared. There we go. So that is term 1. That's what it's going to look like there. Then the second circle, the area of the second circle would be, again, pi, and then the radius of that one is 3. Okay, and they said the sum, so I'm going to add. So this is a series, so squared. Okay, radius squared. And then the third one is going to be pi, and then the radius is 3/2, so 3/2 squared. And this keeps going. And they want us to find the sum of the first 10 circles. Okay, so till term 10. You don't have to go find out what exactly term 10 is. This is the sum of these. So to find the sum of this series, we can just focus on finding the key things. You need to find the value of A. The first term in this series is pi times 6 squared. And then you need to find the value of R. What is the ratio? Okay, you could have thought about it, but you can also just say term 2 divided by term 1. And so that would be the pi times 3 squared divided by pi times 6 squared. Well, your pi's cancel and then numbers really. And then 3 squared divided by 6 squared, that's going to give you a quarter. Here's why I say because it's 3/6 squared. Okay, that gives you a half. Half squared is a quarter. So that gives you a quarter. So you see we have all the information we need to find that. So they asked for the sum of these areas. So let's use the sum formula. So here's our sum formula and we're just going to substitute. So we are saying the sum of 10 terms, right? 10 circles is equal to our A value is pi times 6 squared and then multiplied by our ratio is 1/4. And we raise it to the power of n, which is 10. And then we have -1 all over and r minus 1. So that's 1/4 minus 1. And then we just plug that into the calculator and let's see what we get. And we get a decimal, so which is understandable because it's the area and these radiuses, they start becoming fractions. So here we have 150 point and we're going to round off to 2 decimal places. You see that 6 is going to round up and cause the 9 to become a 1. So that rounds to the 7. So that becomes 8. So we can leave it as 80. And this is the area. So we're going to leave it as centimeters squared. That would be the sum of those 10 circles. Okay, that is it for 3.2. And then we move on to 3.3. Question 3.3 says, which circle has a diameter of 3/128 centimeters? Okay, which circle has a diameter? You see, with this, we already have the radiuses of these circles. I don't want to work with the radius because the thing is you're going to have to still remember, okay, the radius is twice the diameter is twice the radius, and I don't want to have to remember that. So let's form a new, and it's for 4 marks, so we can do this. Let's form a new pattern with the diameters of each circle. Okay, so a lot of patterns that we use here from the same information. So these ones are the diameters that we're going to have. So first diameter of the first circle. Remember that the radius of the first circle is 6. So the diameter of this first circle is double of this, 12. And then of the second one, it's just going to be half of it. Still the same pattern going on. That's going to be half of that. And then the third one is going to be half of that. So this is going to be 6 and this is going to be 3. Okay, you could have also just doubled it from here. See, double of that is 6, double of that is 3. Okay, so these are the diameters, and we need to find out which diameter, okay, of circle what, so Tn, is equal to 3 over 128. This is just a Tn question. But remember that this series sequence, okay, this is a geometric. So let's go ahead and write the general form of a geometric sequence. The formula of that is a times r to the power of n minus 1, right? And we know what Tn is because we need to find out which term, which circle is this. Okay, circle number what? This is circle number 1, circle 2, and so on. So let's find that. It's going to be 3 over 128 is equal to, our a value is 12. Our r, it will not change. Still the same thing. We're just looking at a different aspect of these circles, the diameters instead. So it's still going to be a half. You can check. 6 divided by 12 is a half. So the power of n minus 1. And they just want us to solve for n in this equation. So we're looking at this and we're trying to get to n. The first thing that is stopping us from getting to n, apart from everything here, is the 12. So we need to get rid of 12 by dividing both hand sides by 12. So divide by 12. Now, of course, here you can say on your calculator 3 over 128 and actually use the division, okay, division sign. And when I do that, I get 1 over 512. And this is equal to, so this part now we're going to have, that cancels, and you're left with 1 over 2 raised to the power of n minus 1. Now, this is actually just an exponential equation because the thing you're looking for is in the exponent. So you're going to have to make your bases the same. So how do we make 1 over 512 a base of a half? Well, 512 can actually be a base of 2. See, if you say 512 and you say shift fact, you see that that gives you 2 to the power of 9. So it means that you have 1 over 2 to the power of 9. But here's the thing about 1. 1 can be expressed as 1 to the power of 9 and it will still stay 1. So that means that we can actually write this fraction as 1 over 2 all to the power of 9 is equal to then 1 over 2 to the power of n minus 1. And now the bases are the same. So equate the exponents. 9 is equal to, I'm just going to write it as n minus 1 is equal to 9. And then solve for n. We'll just take your negative 1 over and that becomes 9 plus 1, which is 10. So that's what we get. N is equal to 10. So what this means is, which circle has a diameter of this? This is circle number 10. Okay, or the 10th circle. The 10th circle. Okay, so that is it for patterns. It really was not that bad. It's okay. And I'll see you guys in the function section of this paper.